Welcome to the Statistic in ED YouTube channel. Today I want to talk about importing and exporting CSV files in R, a common task. And my main objectives for this video are: 1. To discuss when or when not to use base R's functions to deal with CSV files, and to show you some extension packages that we can use and discuss their advantages, and to benchmark exporting and importing functions to see which is fastest, and also to reason a little bit about the CSV file format itself. So I hope you find that useful. The data we're using today come from the New York City Flights 13 package, which was published by Hadley Wickham. So you can easily access this data just by installing and loading the package. So you don't need to download the data from anywhere. Note that we won't go into much detail what these data contain and what they mean, and we won't analyze it. But you see that the file size is not big data in the gigabyte sense, but at least over 300,000 rows, so it's non-trivial and more suitable for these benchmarks than, let's say, empty cars data. Right, these are the packages we will look at today. So we'll use base R's read.csv and write.csv functions, and we will contrast them to a package from the tidyverse, readr. We will have a look at the vroom package, which makes us think of Formula 1 cars, so it's designed to be blazingly fast. We'll take a look at the readr package, which is a Swiss Army knife for data import and export. So the convenience is that you have one general function import to import different file formats, and you don't need to worry about different functions. And also the same for exporting data, you just have this general export function. And last but not least, the data.table package. Right, so these are the packages we want to compare. And here are some functions that we can use to export the data and write them to disk in a CSV file format. Note that base R by default writes row names to disk. I disabled this here. The other packages don't do that. And also for the vroom package, I specified the delim parameter. Apart from that, we have dedicated functions for the CSV file format in base R and readr. Also for vroom, we have a function that is a bit more general, vroom_write, but vroom is dedicated to delimited files or flat files, so it's not as general as readr, which can export and import more different file formats, and we don't have to worry about different functions. We can just specify the export function. And data.table has a dedicated function, fwrite. Okay, so this is how we can store the data. I stored them to different file names, and you'll see in a moment why. We can compare the file sizes, and we see very quickly that the files cannot be identical because the file sizes differ. The base R file is the largest at 32 megabytes, and tidyverse and vroom also differ a little bit from readr and data.table. Now, to find out more about these differences, we can manually inspect the CSV files, of course, but we can also load the files into memory and then use the compare function from the Waldo package to find out more about the differences. You can see more of the code on my GitHub and in the code for this presentation. It's a xaringan presentation created completely from within R. And you can see that the packages differ in how they encode date-time columns, which is, I think, important to know, or good to know at least, and also how they treat missing values. Sometimes just empty cells are written, sometimes explicit NAs are written to disk. We talked about the row names in base R, I already disabled that. And also note that when you load the data back into memory, you may get different classes for the object type that you import depending on the package. They're all data frames, but you may get a class data.table or tibble on top of it, depending on whether you use data.table or the tidyverse. Okay, but now on to the benchmarks. How do these functions that we just saw compare in speed? So here we use the bench package to benchmark these functions, and note that for the plot on the left, the x-axis denoting time is on a log scale. So base R is really by far the slowest function that we have here. It takes over 10 seconds. readr is much faster but slower than the other packages. Vroom is the next, and the clear winners are Rio and data.table. So I'd say data.table is the definite winner because Rio does not re-implement a CSV exporting function, but just uses data.table in the background. So the strength of the Rio package is that you don't need to worry about a dedicated function, but you can just use the export function as a general exporting function and just specify the file, and the extension tells Rio which package to use in the background. And here it uses data.table to make use of data.table's blazing speed. Right, so we have a clear winner in data.table, and now we can straight move on to importing these files again and see which importing functions are fastest or how they compare using the same benchmark function, the mark function from bench package. And we get a similar picture. Again, baseR is by far the slowest. It's the only function that takes more than a second, 1.5 seconds. The others are well below a second. readr is again much faster in second place, but beaten by the vroom package, and the clear winner again is data.table alongside Rio, which again uses data.table in the background. So data.table wins both competitions for importing and exporting data, and Rio is very convenient for the generalized functions, export and import. Okay, now a note on the CSV file format. For comparison, I also saved the flights data in R's internal data formats, RDS and RDA. The difference is that when you load the data in the RDS format, you can specify an object name, whereas for the RDA format, the object name is part of the file. So RDS, I'd recommend that because it lowers the risk of overwriting objects in your global environment. Apart from that, the file sizes are the same, and you see a huge difference. While the CSV file is almost 30 megabytes, the R internal formats are below 7 megabytes. So it's a compression factor of more than 4. So CSV is not an efficient format for storing data. Of course, there may be situations where you're forced for external reasons to stick with the CSV file format, then that's fine. But if you have a choice which file format to use, I'd rather use an R internal file format because it's stored much more efficiently. Right, to finish off, a little summary. We saw that for both data import and data export, data.table won by a large margin. It's the fastest. We also saw that for data export, the files may differ slightly depending on which package to use. There are some differences in how the data are stored in disk. We did not take a close look at the vroom package. So if you have really large data and you don't want to load the data in memory completely at once, vroom provides functions for lazy loading, or takes care of lazy loading automatically in the background, I should rather say. It makes use of the ltrap framework. It offers indexing and even multiple threads. So if you have large data, really large data, and want to make use of lazy loading, then vroom deserves a closer look. And finally, when to use baseR's read.csv and write.csv compared to extension packages. There are two valid reasons I can think of. One is when you want to avoid dependencies on external packages. That can be a good idea in projects, or when you create your own packages and you need functions for data import and export, you may want to reduce external dependencies. But if you do so for your own packages, or for your own projects, I should rather say, you can have a look at the Rnv package that you can use in combination with RStudio projects. That can really help to alleviate the so-called dependency hell. You can get a dedicated package folder in your project, inside your project, so that even when you do package updates for your general R installation, you can still keep your project isolated, so that you can rest assured it will still work in 6 months' time or in 2 years' time even. Even when packages are updated and functions may change. A second reason to use baseR's functions is when file sizes are moderate or runtimes are not critical, then it's okay maybe to stay with baseR. But apart from that, we saw that the speed differences are really massive, and it can be worthwhile using data.table or another faster package. Also note that readr is more explicit about how column types are parsed, so that's also an advantage compared to base R. Right, that was it for today. I hope you found that useful. If you liked the video, give it a thumbs up. Consider subscribing to the channel if you haven't already. Check out my other videos. All the best for your own data analysis. See you next time. Ciao.